In this section, I'm going to show you how to write out ionic formulas, also known as empirical formulas, and making sure you have the correct ratio when you write them out. The first example I'm going to do for you is sodium and chlorine. So we need to know their charges from the periodic table, which you should be an expert at by now. If I look at sodium and chlorine, sodium has a +1 charge and chlorine has a -1 charge. Now the number one thing you need to know about writing ionic formulas is that in the end, the charge must be neutral. So if you see here, I have a sodium with a +1 and chlorine with a -1. If I were to add +1 and -1 together, I would have a charge of 0, which is neutral. So what I know is it takes 1 sodium to do that and 1 chlorine to do that. And that way I know it would be neutral. So I write this out as NaCl. Just 1 sodium and 1 chlorine. That's a pretty simple one. So let's look at lithium and nitrogen. If you look up lithium on the periodic table, you'll find out it has a +1, and nitrogen, being in group 15, has a charge of -3. Well, in order for these to be neutral, it looks to me like I'm going to need 3 lithiums to give us a +3 charge and 1 nitrogen to give us a -3 charge. If I take +3 and -3 and add it together, I get 0. So the way I'm going to show that I need 3 lithiums and 1 nitrogen is I write lithium with a subscript of 3 and nitrogen with no subscript at all, but you must remember that that means there is 1 nitrogen. In this next example, we have copper and phosphorus. Now copper is a transition metal, which means it can have more than 1 charge. In this case, we've used Roman numerals to tell us its charge. Transition metals are always positive, so in this case copper is a +2. So when I write these out, copper has a +2 and phosphorus, being in group 15, has a charge of -3. Well, neither of these will go into each other, but they both go into 6. I can get copper to become +6 and I can get phosphorus to become -6. But in order to do that, I'm going to have 3 coppers, each being a +2, and I'm going to have 2 phosphoruses, each being a -3. So in order to show that, I need to show that I have 3 coppers and 2 phosphoruses. So I write those numbers as subscripts. There is a shortcut method to figuring out these formulas. It's called the crisscross formula. What you do in this case is you take the charge of each of the ions and crisscross it to become the subscript of the other ion. Let's go through this example. Calcium has a 2+ charge, so I'm going to look at the 2. I'm going to cross that down and have that become the subscript of the chlorine. The chlorine has a -1, even though it just said negative. So I'm going to take that 1 and crisscross it down, and it becomes the subscript for the calcium. So now I know that I need 1 calcium and 2 chlorines. So I'm going to write that out. 1 calcium and 2 chlorines, just like I do in my other way of writing formulas. But of course, as chemists, we don't write that 1. We just ignore it and put down CaCl2. That shows us that the ratio of calcium to chlorine in this ionic compound is a 1:2 ratio. Here's another example of the crisscross formula. Notice that calcium has a 2+ charge and oxygen has a 2- charge. Now if you remember the first method I taught you, you know that a 2+ charge and a 2- charge equal a neutral compound, which is what we would want in the first place. It would only take 1 of each of them. So if you crisscross these two, you would get Ca2O2. But remember, an ionic formula just shows the ratio of the ions in a salt. Since it has a 2:2 ratio here, we will reduce it and get rid of those subscripts and become just a 1:1. Just 1 calcium for every 1 oxygen. Polyatomic ions are ions made up of more than 1 atom and they have a charge. Here are some examples. There are several polyatomic ions that you should know for the future, and there's no way to get around it other than to memorize them. Nitrate is 1 nitrogen and 3 oxygens, and it has a charge of -1. Sulfate has 1 sulfur and 4 oxygens, and it has a charge of -2. and then there's sulfite, phosphate, ammonium, and hydronium. These are all examples of polyatomic ions. The key to writing ionic compounds using polyatomic ions is to make sure that that polyatomic ion stays together at all times. Notice here we have aluminum with a 3+ charge because it's in group 13, and sulfate, SO4, with a -2 charge. Remember, the SO4 represents sulfate, so do not ever separate that sulfate when you're writing out the formula. So I write down both of the ions that we're going to be dealing with in this salt. I notice that aluminum has a 3+ charge and sulfate has a -2 charge. So I'm going to crisscross and get our resulting formula. The 2 from the sulfate 2- goes down and now tells us that we need 2 aluminums. The 3 from the aluminum is going to crisscross and tell us we need 3 sulfates. But remember, I told you we need to keep the SO4 together. So the way we do that is we put parentheses around it, like so. And now we need 3 of those sulfates, so it becomes Al2 and then SO4 in parentheses with a 3. Notice we have 2 aluminums and 3 sulfates.